Hello, we will see the place 2D texture node in Maya. If you see the Hypershade, we have the 2D textures, and if I take the file node, you have this file and you have the place 2D texture node. So for all the 2D textures, you'll get a place 2D texture node. So we'll see what this place 2D texture node is all about. My name is Vishal Rain. So let's see how this node works. So for that, I'll be taking a plane. In Maya, we have different methods in which we apply the texture to the model. One is in the classic UV unwrapping method, where we have the model and we have a virtual skin which we have in the UV editor. So we have a 3D model here and we have the skin of the model. We label this skin, and based on the placement of the UVs within the tile, the texture can be seen here on the model. Apart from that, we have 3D texture which works based on the object's placement in the viewport, and we have projection method, we have poly painting method. So we have different types in which we can color the models. So UV method is most popular method used, which works with different softwares. So in Hypershade, firstly I would like to go to the surface and then explore the Lambert shader here, and then click it, and then you get this Lambert shader. So if you see, this is Lambert 3. I can right click on this and then rename, and then you can name it as per your requirement. So this particular shader has to be assigned to the model. One way to assign this shader to the model is middle mouse drag and drop onto the model, or select the model, right click on the shader and assign material to viewport selection. Now we have different 2D textures here. I can delete all of them and then create freshly new one. So I take any of these nodes, I get this place 2D texture. So this node is a very common node which can be seen through all the 2D textures. So placement node sends information into the texture node. From the texture node, you can send information to the shader node. So we have two possible outputs. One is the color and another one is the alpha. Alpha is a single channel information and color is the 3 channel information. So in normal procedural textures, whatever we have in the color, we have that in the alpha, which is a value based map. But in the file, we have to open a JPEG or any PNG or any 2D file format images, and alpha can be possibly there in some of the file formats like Targa, TIFF. So if I generally choose JPEG, I may not have alpha file or alpha channel in it. So I should be aware that my file node has alpha in it. So right now I don't want to complicate this. The color information should go to the color of the shader. So if you see, Lambert has got color, transparency, ambient color, incandescence, bump, diffuse, translucence, translucence depth, and focus. If you notice, we have a color swatch here. So color swatch needs a connection with 3 channel information, whereas the diffuse, which is the single channel information, so either I can connect the red to the diffuse or green to the diffuse, blue to the diffuse, or alpha to the diffuse, but you should be aware what that particular channel carries. So right now I just want to connect the color to the color. That's how it works. Okay, so the file node right now is a empty file. I need to browse image. I'm browsing an image which is having arrow in it. Now if you select the model and open UV editor, okay, the arrow is facing upside, okay, and it is stretching through one box in the UV editor. UV editor is the place where you edit UVs of the model. As I said, UVs represent a virtual skin of your 3D model, and it works like label of a particular 3D model. Consider label of a carbonated drink bottle. So here we have this UVs. I can go to the image section and I can generally brighten up or darken the image, and we can basically use shaded mode where you could see the UVs. Okay, so we'll try to understand this space a little bit. This space is generally a 2D space, and here is the origin, the 0 point. From there you have positive 1, 2, 3, 4, and it goes to infinity. And this side you have -1, -2, and infinity as we go further. And on this side you have again 1, 2, and infinity, -1, -2, and infinity. So this tile is the first tile. It is called as normal or 0 to 1 tile, where your default UVs will exist. Now there could be a question whether we can put the UVs outside this tile. We can absolutely put the UVs outside the tile, but what happens in the next tile is the same image gets repeated there. and you can see the effect of the, you see when I change the UV placement from here till here, again I see the same arrow on the model. I put it here, again you get the arrow. So every tile carries the same image, but we prefer to keep our UVs in the first tile. We have something called UDIM tiles or multi-tile concept, where we can use further advanced method of using more space of the UVs for high quality textures. But for now, as we are discussing about place 2D texture, we are trying to understand this. Now, as we have a vertex in the viewport which allows me to move the points of the model, here in the space we have the UVs which can be which you can generally possibly alter the shape of. Based on the change, you see the result getting affected. When I put all the UVs in the green color area, I got the total model getting its green color. When I put it in the checker panel with the cross, you see very similar placement. So the UVs which we put in the tile, based on the UVs placement over the image, we get the result accordingly. So how about altering this image? This is where our placement node comes. So we have this place 2D texture node. When we double click it, we get the attributes for this node. And what you see is two boxes. So the first box represents the U, the second box represents the V. As in viewport we have X, Y and Z axis, in the UV editor we have U, V axes. So if I move the UVs left to right, I am moving in the U. Vertically, I am moving in the V direction. So I select the place node, and then we have this option here called coverage. So we have the coverage. Right now the values are set to 1. So if I put a value of 0.5 and 0.5, you see you are getting the arrow only stretched to 0.5 value of the total tile. So from here 0 to 0.5 I got my image, and from there I have something gray here. If you notice the coverage is an option which allows me to cover or stretch the texture in the tile here. How far this texture covers my tile is what the coverage means. So if you see the coverage with a value of 0.5, will only stretch the image to 0.5 units of the total tile. If I put a value of 0.2, it only stretches till 0.2 units. If I increase this value higher than 1, so it stretches beyond that, and you don't see the tile anymore there after that. So there is a cut there. So if I put a value of 0.5 and 0.5, you see you got the quarter part of this tile here, 0.5 units from the U, 0.5 units from the V here. So we have this option called translate frame. So if you see the translate frame here, when I'm increasing the value to 0.1, 0.2, 0.5, you see the images keep moving. Okay, I can hold control, click in the box and drag it, and you see the tile keep moving left to right. So you're translating this image, and when the image is translated outside the tile, whatever has been gone outside the tile is repeated from the other side. You see, whatever has been chipped off has been repeated from there. We can enable or disable this feature by wrap option. We can do the translate frame in the V direction also. Like that. You can use this value and animate them. Sometimes you want to create a moving motor belt sort of thing, and you can do this just by animating that and give the effect of something is moving. Even you have created a walk cycle and you want just to get that road moving forward or background painting moving. If it is a seamless texture, just animate that and then you get the effect of moving textures. So this is a very good option. We have the rotate frame option where the texture is rotated around. So we have a repeat option. In repeat option, if I put a value of 5, the arrow is repeated 5 times, and then here 5 times. So it allows me to create tile of textures. And we have this nice option called mirror U and mirror V. So you should see that in this direction every tile is mirroring with the other. Okay, so as these both sides look very similar, I don't see much difference, but V is making some difference there. We have an option called stagger, which you can enable, and then you see there is an offset in the tile there. We have offset. Offset generally is it looks very similar to translate frame, but where this offset works, I'll show you. Even if you see the rotate frame and rotate UV, rotate frame is rotating the overall image, whereas the rotate is rotating per tile. Okay, you see that. So I'll just assign a Lambert shader and create a procedural texture here. Okay, so I'm taking a ramp texture, okay, and changing the interpolation to none, and then creating this pattern. This is U direction, this is V direction. So I'll go to the repeat V, put a value of 5. So you got something like this. Okay, cool. I'm just trying to make a flag which I've seen earlier somewhere. So I'm taking a blue color and a white color. Okay, so let me open Hypershade. Right click, graph network. So I've got a ramp. I'm taking another ramp here. Okay, I'll take a single color and connect the color. And I go to the placement node and just have a look. I'm using a coverage value of 0.5 and 0.5, and I just want to move this tile up. So I'll put a value of 0.5. Now you should be able to see the white color and the gray color. So I'll open the Hypershade. White color connection can be connected here, whereas the gray color can be done in the color balance default color. So I'll connect these stripes to the default color. Just use middle mouse, drag and drop. I should be able to see the stripes and a patch which I have made here. Now in this area, you do any changes will affect that part. Okay, now here I'll take another ramp. Okay, and I'll change the interpolation to none and ramp type to box. You should see the box, white color and black color. Okay, so I'll take this. Now what I do is I use the placement repeat 0.5, 0.5, 0.5, 0.5. Now what that actually should give is, you should see, okay, what I do is I just reset the values. Now I should see here a box, right? Now I select the placement node and use the translate value to 0.5 to 0.5. You should see a plus sign, right? But I want the plus sign only to be in that particular corner. So I'll reset values and then put the coverage value of 0.5, 0.5. Now if you change the translate, I don't get the plus sign there. Okay, I don't get the plus sign. Translate doesn't work there. You should see that. Okay, so I possibly make that tile going up. Now how do I get the plus sign? Is just change the repeat value to 0.5 to 0.5. So offsets the texture here, and translate will translate the overall frame here. There's a difference between the translate frame and the offset frame, and you have rotation frame and then rotate UV, which works again very individually. Okay, okay, the texture is not getting updated in the viewport, but we'll see that in the render. I'm choosing Maya software and then render it. Okay, Now you see the stripes and then a flag there. So that is the offset frame and the rotate UV option in comparison with the translate frame and the rotate frame option. So yeah, now we'll see what that noise does. It's a very simple thing to deal with. Okay, just put a value of 0.1 and you should see certain amount of distortion in the texture. Quite useful. In creating such patterns, if you are not having any you're expecting such random wave like thing which you don't have in the normal ramp texture by default. We have the wave option here. Okay, and we have the noise option here, but these are very different from that noise. So this is inbuilt option for the texture, whereas this one is the option which can work for any of your textures you got with. Fast enables you to, it computes fastly, which will leave the render lags behind. Somewhere again the quality is compromised, but yeah, you can enable this option. We have interactive placement here, and we can control interactively the textures here. In polygons you may not able to see the placement, but maybe if you choose a NURB surface, maybe you can do that, but again need to check with. So I'll choose interactive placement. I can just click and drag that points somewhere. Yeah, that's how it works, but yeah, I'm not able to. So use left mouse button to select the new surface and middle mouse button for modifying the placement node. Now you see I'm able to modify. I need to use middle mouse button there, like that. So I can interactively do the coverage thing and the placement thing, the translate frame, I can say, like that. Okay, that's how interactive placement works. So yeah, that's how the overall video goes. Hope you liked this video. Thank you very much. Let's see 3D texture and also compare this with the 2D texture. So we have the model here. As I said, to apply colors to the model, one way is you do with the UVs. Another way is directly you get the texture based on the placement of the model in the 3D space. So let's try to understand this in detail. So I got this polygonal sphere, and I'll open the UV editor, and you should able to see the UVs. I select this line here, I'll cut it. I'll cut it here, I'll cut it here. I'll apply move and sieve. Move and sieve. Now I just apply unfold. And then apply layout and all those shells. Now I just wanted them to cut. I just want the 4 panels here. Okay, firstly I'll just duplicate this model. Okay, and for the first sphere I'll assign a Lambert shader and an attribute editor. Let's name this as 2D texture. Assign Lambert shader. .3D texture. So it's not taking the 3. Okay. So in the first texture here, I'll apply any of the 2D texture. So I'll be taking the fractal 2D texture, and for this I'll be taking the 3D texture. Very similarly, I'll take solid fractal. Okay. Now if you see, the 2D texture is getting the texture based on the UV placement here. Okay. So if I select the UVs and move them, I could see there is a change in the texture there. So it's like the skin or some sort of sticker. We are pasting it over our model. So we get the sticker from here and then we are pasting it there. So if I just move the shell somewhere else, so it takes a different texture and you get the different placement of the texture there. Okay. So for 2D textures to work, we should have the UVs correctly unwrapped and placed properly in the tile. But for the 3D texture, the UVs doesn't really matter because the texture's placement is based on the object's placement in the viewport. The texture exists in the 3D space, just like clouds in the sky. Though they are not visible, but if I select the model and move, you see the textures keep changing there. I will take, instead of solid fractal, I'll take the crater texture, which will have more colorful. Don't worry about the seams here. It is because for Maya to show the result in the viewport, it temporarily bakes into texture and it will display U. But if I start moving this, the texture keeps changing. So this is not interactive. The crater is getting baked onto the model and I'm not able to see it interactively in viewport. There is a problem. I will open the IPR render and then move the texture. Crater is not showing the real-time result, so I'll go back to our okay, let's see the volume noise, if it will show up. Yeah, it's showing up, you could see that. Okay, so if you see, the model has got the texture based on the object's position in the viewport. So if I by say use or animate the object in the viewport, I get this boiling effect because the texture is staying there and the object is moving away from the texture. You scale the object or you rotate the object, you get this boiling effect. In rotation, as this is a 3D, this is a sphere, you may not able to see much difference. But if I take a cube and assign this texture and rotate, you see the effect on the model. Okay. So if you're getting this boiling sort of effect, just take care of which sort of texture you have taken. Okay. Now if you just get into the Hypershade, we have place 3D texture. For place 2D texture, the node is 2-dimensional with T. For this, you got a box with the T. So, like any model has got the transform node, our placement node is also a transform node. Okay, which you can see in the viewport here. So as I've created volume noise, fractal and crater, we have the placement nodes of these 3 objects. So this is the texture which we can move. Rotate and scale. So the placement works like that. So we don't need any UV editor or UV unwrapping when we are using the 3D textures. So it doesn't really count the seams as such like what we have in the 2D. There is a differential seam there, but here you don't get any such problem in 3D textures. So when we are animating a 3D texture model, we get this boiling effect. Unless until it is a non-deforming object, you can fix the problem. For that, you can just open outliner and see like any other objects. Okay, I'll just delete this too. This is a object. You can select this object, which is a placement 3D texture, and select the sphere. Go to edit and then choose parent. I can select the object and move. You don't get the boiling effect there. I'm seeing only the sphere. Okay, there is no boiling effect. Here we are seeing boiling effect because the object and the placement node, they keep changing in relation with. Okay, but if this model, if the sphere gets distorted, let's say you have applied any deformer, anything, even you have applied you get the boiling effect. You see the textures keep changing there. These textures are very much suitable for organic models. For example, I'll take a Boolean model. I'll take a polygonal sphere. Okay, and then a cube. Then in modeling, Booleans difference. Okay, now if I apply the texture, there would be a texture continuity. Just like if you slice a rock, how the continuity of the details through the cross section happens, you get that similarly here. Okay, you see the continuity of the texture even you have sliced up the rock there. If I apply a 2D texture, in that case you don't get the continuity happening. You could see a stretched UV here and a differently placed UV here. There is no continuity at all between these two areas. So 2D texture works like a skin over the model, just like an apple, a skin. 3D texture is like a rock, a marble stone. Even you slice the stone, you see the continuity of the texture. So that is the 3D texture for you and the comparison too. The placement node is very simple, as I said. It doesn't have anything much. It is like any transform node. It is like any other transform node which you can scale just by selecting the node, and the textures keep working for them. So there's not much complexity as like you have in the 2D texture as. Hope you like this.